Okay, so again, instead of just in terms of practicing data mining, there are some philosophical questions that we can think about. So we talk about roles in data mining. How active should the researcher and other parties be in the process? So, of course, human intelligence can add to the process. However, it can also bias the results by ignoring important but previously unknown patterns. So humans, they're going to sort of look for results that they sort of expect or know about, whereas maybe a computer doesn't do that. So we could say that that's a kind of bias that humans will inject into the study. So the question is, how automated should the process be? Would it be possible to have an intelligent computer that could run the whole process and thus perhaps avoid the process? No, avoid the bias, I should say. Right, this is a question for the future. So we also talk about something called the domain expert. So if you're doing a medical study, the domain expert might be a doctor. If you're doing a study about economics, the domain expert might be an economist. If you're doing a study about marketing, the domain expert would be someone involved in marketing. But you could be doing the data mining part of it, and you'd have a separate domain expert, suppose a marketing expert, which would help you, or you would help them with the results. So domain experts, those who have extensive knowledge about the area of the application. For example, if you or I were to run a data mining experiment on DNA-related data, we would uncountably miss so many important considerations. The same would be true if we were to run it on creditworthiness of loan applicants, right? This points to the essential role of the domain expert. Domain experts can advise on which patterns are interesting and useful, and what actions to take in correspondence with the patterns. They can also help in selecting and pre-processing the data. However, as mentioned earlier, domain experts can add bias into the process. So we might look for a compromise. We might recognize humans are good at spotting trends, while computers are good at searching through large volumes of data. Okay, another thing is we talk about data mining approaches. We can consider two different approaches. One is called hypothesis testing. The other is called discovery. Hypothesis testing is a traditional statistics approach, whereas discovery approach is sort of considered less desirable by statisticians. Hypothesis testing is a preconceived statement, a hypothesis is formed. Then data is collected in order to test the hypothesis. Normally, evidence supporting the hypothesis is compared with that for evidence against it, or in other words, for a default hypothesis called the null hypothesis. The proposed hypothesis is only accepted when the support is really there, when the support is significantly higher than the support for the null hypothesis, or for the other hypothesis, or for the other possibility. For example, in medicine, we might ask, do eating habits contribute to the likelihood of mad cow disease? So I guess you know about mad cow disease. For instance, the human form of mad cow disease might be related to people's eating habits. An initial hypothesis may state that excessive consumption of burgers leads to a high risk of having the disease. So that would be the hypothesis. So we're testing that hypothesis. So you might have that hypothesis actually before you look at the data. Data about burger consumption by people who have the disease and people who do not such as frequencies and amounts of regular burger consumption and other diets, are collected. So we collect the data, the relevant data. After the data are prepared, association rules that express the link between burger consumption and the disease may be discovered. So we might come up with some rule that says if you eat more than 4 hamburgers a week, that you're the likelihood of getting BSE is twice as high as people who only have 1 hamburger a week. That would be called an association rule that express a link between burger consumption and the disease. The lift factors of the rules are measured. Well, we'll talk about what lift factors are in the future. The result of the measurement may indicate that the lift of any of the association rules is so low that it is not significantly different from the lift factor of the null hypothesis. So basically that means that the data is not very strong. So that the presence of the disease is not correlated with the consumption of burgers. It happens by chance. Therefore, the original hypothesis has not been substantiated. This is not to conclude that there is no link, but merely to state that the link is not strong. So the discovery approach, as opposed to the hypothesis testing, whereas in the hypothesis approach we start with the hypothesis. We start with a hypothesis. In the discovery approach, we start with the data, just with the data, and just see what we find. So we don't have any hypothesis in mind. We just throw the data into the data mining process and see what happens. So it's more exploratory. And they often use the words supervised versus unsupervised. Learning here. Also called directed versus undirected learning. So what does that mean? Supervised learning. In supervised learning we have an output variable, or a so-called class variable. It's also called a target variable. So we've actually already talked about this kind of process before in previous videos when we talked about the fertilizer crop yield. So remember in that example, we were wondering whether fertilizer improved the crop. In other words, by increasing the amount of fertilizer, do we increase the crop yield? Right? So in that case, the output variable, or the target variable, or the class variable is the yield. So we say if we increase the fertilizer, how much increase do we get in yield, right? So we're wondering whether fertilizer causes an increase in yield. So it's yield that we're trying to predict. Okay, so yield is the target variable, or the class variable, or the output variable. Okay, we're going to need to use that word often. Class variable, or output variable, or target variable. We also saw it in the iris flower data. Remember, in that case, we had the petal data, and we had the sepal data. So we had the petal and sepal lengths and widths, and we tried from that to predict which class, which type of flower it was, right? So in that case, the output that we're trying to predict is which type of there are 3 possible types of iris, and which one it is. So the output variable is which type of iris it is. And the inputs are the sepal length, sepal width, petal length, and petal width. And we also had the same kind of scenario with the weather and golf data. Remember, in that case we had the outlook, and the humidity, and the temperature, and something else. And then we were trying to predict whether the group would play golf or not. right? So that was the inputs were the weather, like the outlook and the temperature and the humidity and the windiness it was, and the output is to play or not. So we're trying to predict there whether they play or not. So that's the output variable. That's the class variable. That's the target variable that we're trying to predict. All of these are examples of what's called supervised learning. So supervised learning is when you have an output variable. So we actually haven't seen any examples of non-supervised learning yet, but we will. Unlike the hypothesis testing approach, the discovery approach starts with data and induces possible patterns without a specific hypothesis in mind. This approach is investigative in nature. To a certain extent, this is the main factor that differentiates data mining and machine learning from more traditional statistical analyses. Learning from data can be directed or undirected. We haven't seen undirected yet, actually. A directed discovery, also known as supervised learning in machine learning terms, means that the discovery is driven by the outcomes of an output variable. The discovery is to find patterns relating to the outcomes. A typical piece of data mining in this approach is classification. So classifying whether what kind of iris it is, or whether they're going to play or not, where we select the target variable and direct the computer to tell us how the other variables are related to the outcome of the target variable. In undirected discovery, we haven't done that yet, also known as unsupervised learning, there is no specification of a target variable. The computer investigates relationships of some kind between variables or between data objects and measures their degree of significance. A typical example of this approach is association rule mining, but we haven't seen that yet. So, going back to supervised learning, in these examples, there was always something we were trying to predict. Yield, in the crop yield, in the fertilizer crop yield example. Class, in terms of the iris, which type of iris it was. Or play and not play. So this is called the output variable in the first example. This is called the output variable in the second example. And this is called the output variable in the third example. Unsupervised learning. We have yet to see any examples of unsupervised learning, but we will later. An example might be trying to group a large group of customers into different categories, and we'll look at this later.